let's move on to summary. Here zeroth order, here first order, here second order. In first order reactions, the rate is equal to K. In first order, it is R equal K A. If the reaction is A, will form products. With respect to second order, R is equal K A square. Okay. What is the rate equations? What are the rate equations? You can remember that here A is equal minus Kt plus A naught in zeroth order. In first order it was ln A is equal Kt minus Kt plus ln A naught. Okay, what was the rate equation for second order reactions? That was very easy. 1 over A is equal Kt plus 1 over A naught. It was very easy. What about the half-life? Half-life of zeroth order reaction was T half equal A naught divided by 2K. What about the half-life of first order reactions? It was T half is equal ln 2 divided by K. What about the half-life of second order reactions? It was T half was equal 1 over K A naught. Okay, so what was the rate? Units of rate constant. Here I introduced a common equation m 1 minus n t minus 1. According to that, here in zeroth order n equal 0, so m t 1 t minus 1. This is the units of k. What about the first order? In first order, m 1 minus 1 t minus 1. Positive 1 and negative 1 mean m is here 0. What about this? Here m 1 minus 2 t minus 1, that means m equal negative 1. This is the units of rate constant of second order reactions. What about the graphs? According to this rate, what about the rates? Here rate versus concentration diagram. It was a constant in first order reactions, zeroth order reactions. In second order reactions, rate versus concentration was like this. What about the second order reactions? Rate versus concentration was like this. It increased gradually. If we here, it is always constant. It is obvious. Here, if we increase concentration by 1, it will be 1. Rate also 1. If we increase by 2, rate also 2. Doesn't matter. However, this in second order reactions, if we increase concentration by 2, rate will be 4. If we increase concentration by 3, rate will be 9. Likewise, it's increased very drastically. So, here it is increased gradually, here it is drastically increased, rapidly rocketed. That's the rate. What about the equation graph for this? This integral form graph, it was A here t, it was like this, negative gradient. In here also it has a negative gradient, it was minus k. Here ln A, here t, it also minus k gradient. What about here? it also has a positive gradient and positive intercept. All of this has positive intercept, that's why it has a positive intercept. However, here it has a positive intercept and positive gradient, that means its graph was like this. Okay, these are the main things you have to know when we comparing first zeroth order, first order and second order reactions. So this is the summary and other things. If you consider half-lives in zeroth order reactions, if we increase initial concentration, half-life will be higher. Here half-life is not affected by the concentration. In first order reaction, half-life is not affected by the concentration. Not affected. However, in second order reactions, the thing is opposite, because T half, it is inversely proportional to initial concentrations. That means if initial concentration is higher, T half will be lower. Those are the connections. So please keep those things in your mind, and this is the summary of chemical kinetics in this level, university first year and A-level examination level. So please keep this in mind. Actually, these integral forms are not used in advanced levels. However, in university level, these are the basic things. Okay, after this video, I will introduce another video for biochemistry, the kinetics of enzymes. It will be another subject, biochemistry. So if you understand these lessons, please subscribe my channel and please share these videos with your friends, and thank you. Help me to help you.